Thanks, everyone. Yeah, I work at Hive in London. It's a smart homes company. We do like thermostats and light bulbs that you can control even when you're on the other side of the world, which is super useful. And we decided to develop our old customer-facing apps with React Native now to sort of like save up on money and development time. And for the last 6 months, I have been part of the team that was sort of diving deep into performance because we obviously had performance issues. And today I would like to talk a bit about our journey, about the issues that we actually faced, and then some sort of general React JavaScript patterns, okay. General JavaScript patterns that could be useful for wider audience. And at the very end, also talk a bit about the native side only. So like performance is a really tricky topic because it's difficult, you know, we don't usually know how to measure it. When we see measurements, we don't really know what they mean because they are chaotic. And it's at the same time the sort of like a wild card in any discussion, you know, if you're wondering whether to use a new library or not, if you say it's more performant, it's much more likely to be picked up, although we base this idea on something that we don't really know about. We make a lot of assumptions that sometimes end up being incorrect. So really, it's nothing's ever easy, is it? So this whole talk will be about how to make it easy. And in order to make it easy for you guys, I'll share some patterns with you and also show you how you can figure out where the issues in your app are. But at the same time, I'd like to warn you against pre-optimization to begin with, because unless you measure things, unless you actually hit some issues first, then saying that something is more performant or less performant is just a theoretical thing. And it so might happen that in your particular app, things will end up being different than from our app. So that's why I'll be focusing a lot on the tooling around it as well. So the actual issues we hit were partly very sort of specific to native, but the last two, the sort of jagged or slow animation and slow response to user action, is something that you might have noticed in your apps as well, even in web. And those are the issues that I'd like to focus on mainly. This is like me trying to illustrate things that are very difficult to illustrate. Because when we were trying to figure out what is slow about a React Native app, we first needed to figure out what was the reason it was slow, like what the weak link was in the architecture. So this is the architecture of React Native, although it might not look like it. We've got two threads and a bridge that connects them. We've got the UI thread and the JavaScript thread, and then the React Native bridge that sort of communicates between the two of them. And UI thread is where a lot of the sort of UI rendering is happening, and we made an assumption to begin with that the UI thread is the one that is slow, because, you know, that's kind of the one that's doing the heavy lifting. Or maybe that the React Native bridge is getting stuck, or, you know, it's not actually passing the messages quickly enough or something like that. But it turned out we were completely wrong. Unfortunately, we measured first before we started, you know, trying to work on things. And the way we looked for it was using the developer menu. This is something that you would know if you worked with React Native. At the bottom of the menu, there's this like hidden show performance monitor. And if you click on it, you'll see something like this. And again, it's like, this is where like the numbers start, the numbers that are difficult to understand. But what we care about are the ones on the right side, which is telling us what the UI thread and JavaScript thread are doing. It's in frames per second. We want to see 60 because that's the amount at which the user can't actually tell that something is being slow. So this is what we want to see, but what we usually see is something more like this. Especially, you can notice that in the JavaScript thread, the number can fall. And we saw 30, which is quite low. We saw 15. We saw even minus 30, which might seem a little bit suspicious, but there you go. I was told by a member of React Native team from Facebook not to trust these numbers too much, but if they generally fall down a lot, you will see that the thread is struggling. So we realized our JavaScript thread is doing apparently way too much work, especially when we're navigating from one page to another, or when a user clicks a button to save something. We realize that there is a lot of sort of slowness in the JavaScript. And in order to find out why JavaScript was being really slow, we needed to find the right tooling for that. To illustrate it, I will show you our app. This is the dashboard view that the user sees immediately when they load the app. It's a relatively complex one. We've got, pagination and all the products there, and the products sort of change with time. So it's a relatively complex view, and it was taking way too long to load, and we just couldn't figure out why it was being so slow. And in order to debug it, we used the performance tab in React Native Debugger. It's the same in Chrome, so you can use it in web as well. There is a performance tab, and you can literally measure anything that your JavaScript is doing. And what it gives you is a flame chart, which is yet another thing that is hard to understand when you just see it. It's like, what am I looking at? So I'll walk you through it to show you what our dashboard was doing and why it was a problem. So the first column is mounting the general infrastructure, like the providers and translations, etc. That was quite snappy. The next bit is rendering the actual page, the actual components. But what is the rest, right? What is all of the other work that the app is doing? And the answer is it updates it. It re-renders over and over. And you can see that it goes really deep, and that means that it goes deep in the tree. It starts with the top level component, and it goes through every single child component all the way down, updating everything, re-rendering. And that was adding maybe 5 seconds of work in the JavaScript thread, which was slowing things down massively. So we realized stage change was bad, but because it was causing re-rendering. But the truth is, we didn't really know, and I still don't know why it's bad. I know kind of how it works. I know that it's slow. I know I don't want it to happen, but, kind of hard to tell. Anyway, when there is a change, we re-render stuff. And by change, I mean a change to props or state of your application. So what React does is it figures out which render functions or methods or classes it should be running. Then it produces a part of new virtual DOM tree. Then it checks it against the old tree, and it re-renders the actual UI. The problem is, however, that this whole process of running rendering functions, etc., might not actually produce any change in the UI, but the JavaScript thread will still do all of this heavy work. And we think maybe the reconciliation of comparing whether they should actually update something in the UI is taking a long time. But no matter what it is, we realize that the less we make of change, the fewer changes we make, the better the performance is. And the ultimate answer to not re-rendering is usually should component update. It's fair enough. It's in the React docs as well. But we actually found that it's the unexpected villain in our story. It was causing so many issues that we ended up removing it completely from all of our code base, and we don't want to use should component update anymore. Let me quickly illustrate why that was. Let's say I have a component that renders name and a value, and for some reason, I only want to re-render it when name changes. If the value changes, I don't want to re-render it anymore. So what I do is I do should component update, and I just say, re-render it only when the name changes. 3 months later, another developer comes and says, okay, I need to add a description. I do care about the component re-rendering when description changes, but they don't notice that there is the should component update. And that's where bugs come in. Obviously, when the component is small like this, you can immediately notice there is something you need to do. But if you have a lot of props or really nested view, it's super easy to not spot it. And what started happening to us was that we started having bugs in our application because we tried to make it faster. And I think everyone can agree it's better to have a slow app that is not buggy than to have a buggy app that is fast. Fortunately, React itself is super good at sort of reconciling, figuring out what it should update. It's not going to do any work unless it really has to. But we kind of need to understand how this reconciliation process works so that we can write code that works with it well. So whenever you change a node type, swapping diff for a span or something like that, the whole subtree will remount. That means that the whole thing gets destroyed and remounted as a completely different thing. So we usually don't want to do that at all if we can avoid it. Oh, sorry. Then we've got the change in props or state in a component where it will sort of try to re-render itself and then go to its children and check if the children need to be re-rendered as well. And that works with a shallow equal. So if you change text, it's very easy for it to recognize that there was a change. If you change something within an object, you mutate an object, it's not going to re-render at all because the reference is the same. But let's say if you're using new object every single time you render, it will be a new reference and new re-rendering through the whole subtree. And all of these changes have the potential to propagate to all children. So as a general rule of thumb, if we are re-rendering on a very low level, let's say on like, buttons or something very sort of, granular, we don't care that much. But if it happens on a top level component that causes the whole app to re-render, that's really bad. A few practical examples in this one. We've got some sort of component that changes the wrapper around the children based on type. And as I said, that remounts everything, meaning that all of this stuff, whatever the children might be, if it's like a really complex tree, all of them will get re-rendered every single time you change the type. Not only re-rendered, but also remounted. That's even more work. And if you change a prop, you've got the text, and when you change hello to hello world, the button will re-render. And as I said, it's a recursive update, so if you make a change at the very top level, then React will have to go to the children to check if they need to be re-rendered, and then the children, etc. So it is quite, it sort of bubbles through your application a lot. So let's have a look at a few examples of what to do and what not to do, the patterns in your components. The first example that I find most important is anonymous functions. In our code, we these days have an ESLint rule that warns us against using anonymous functions with the squiggly line. And the reason for that is if I have a component with onClick and I render the parent, every single time I render parent, I re-render the component as well because the reference to the onClick function changes every single time. Obviously, on a low level like this, it's not such a big problem. But if you have an onClick handler somewhere on the top level, this will keep happening over and over. And it becomes, so like we essentially want to like stick in a variable or a class method or something like that so that we are not changing the reference to the function ever. This principle becomes much worse when you're using Redux and you're connecting your state. In connecting your state to any component, you can use map state to props, that's quite the usual one, map dispatch to props, but sometimes there is also a reason to use merge props, which will create a new reference to a function every single time you run it. And connect, or these mapping functions, run every single time you update your Redux store. And if you have a complex Redux store, if you're putting things into Redux store that get updated often, all of this stuff will carry on running over and over and re-rendering everything that's underneath it. So we need to be really careful about not doing this. And the ultimate way of working with this for us was never to use merge props. When we were using map dispatch to props, to only use it as an object so that the reference to the function stays the same. And then map state to props obviously is something that will get run over and over, but as long as the props that are returned from there are either the same or the reference stays the same, we are still fine. And in order to make sure that things are staying the same, when we have the selector that is pulling some data from the store, we ideally want to memoize it. We're using reselect in Hive, but you can use any sort of memoization function, really. And the idea is that A, you will avoid some computation that is unnecessary, but also if you're returning an object or a function or something like that, it is much more likely that it will return the same reference, so it won't re-render needlessly. This is especially important if you're working with immutable or immutable data structures, because they will they will force the re-rendering a lot, and sometimes that's not something that you want. And when it comes to state and working with state properly, there are still a few things to do, but they are not like patterns, they are more like, think about this. So the first thing to focus on is local state and setting state based on props. Let's say that we've got some selected props and we want to say that if it's selected, we want to set the state to updated true. The problem with the first example is, however, that in component did update, the component has just re-rendered, then you set state and it re-renders again. So we have two re-renders straight, one after another. So a better approach is to use get derived state from props, in which case this whole cycle runs only once. But even better, it is to not set state, like local state based on props. It's better to do all of that stuff in the mapping, in the connect, or not do it at all. I think there is a common misconception that like we don't want to do any computations in random functions because they run often, but the truth is a lot of things run often. So we are trying to limit the number of times they are run. Then the next question is actually setting local state necessary? Ideally, you want to set it only when you really, really have to. So for example, if the variable isn't set to the value you would expect to begin with. But there are also other rules, like sometimes we would use set state to memorize things so that we are not running, some computations in render functions. For that, it's better to use an outside memorization and not stick things into state. So local state seriously should just be for things that if I change them, I want the state or I want the UI to be re-rendered. And that's actually maybe, like in our case, it was maybe 50% of the time. The other things were just sort of quite arbitrary. Then there is the idea that, as I said, if you change anything in your Redux store, then all the connects run and everything gets re-rendered. We don't want that. So it's much better to localize things so that you don't re-render the whole app, but you just re-render the specific things you're interested in. A common example is that we tend to put modal state into Redux or form state into Redux. And if we keep that locally, we will prevent a lot of re-renders. And then last thing is that obviously it's not just the fact that we are re-rendering things with Redux, but it's also the fact that we keep changing in our store often way too often. And in our case, for example, when we loaded the application, we dispatched some 16 or 20 functions or actions, and all of them did slightly different things, and all of this sort of accumulated over time. But we realized that if we replace all of those with just one, and all the reducers sort of listen to just that one thing, and sagas listen to that one thing, we had a huge boost. Redux store itself is super slow. We noticed the other day that if we dispatched an empty action that no reducers reacted to, no state reacted to, it took for it to get through the whole cycle around 3 seconds. That's because our store is insanely huge, and there is another issue with that on its own. But that's, it's another thing to be mindful of, try not to use it unless you really have to. And then there is the last thing of connecting state. I think to begin with, we made an assumption that if we connect just one thing, on top level, it will become much easier because we won't we won't actually create that much JSX, we won't have that many higher order components, which somehow in our mind was a good thing. But the problem actually was that meant that we had to pass props throughout the whole tree. And if I change, let's say, name that needs to be used just by this component down there, and I change it on the top level, all of it will get, again, re-rendered because we need to pass the name down the tree. Whereas if I connect it on quite a lower level, then only that part will re-render if the name changes. So that was a huge boost for us as well. So for web, the general conclusions would be, it's always the JavaScript thread, it's always the JavaScript. After I did this talk in Amsterdam, someone came up to me and was like, so actually in our case it was the UI thread. So that was a bit awkward. So it tends to be JavaScript, but it might be also UI, just, measure. Measure before acting every single time. Think about reconciliation and state updates. I showed you a few patterns that we found useful, but this is something, the reconciliation process is quite straightforward. And if you really think about how that works, it will help you write better code overall. And memorize. Or just use more backs. I was told that yesterday. It's that sort of by default deletes a lot of these issues. So let's have a look at the native-only stuff. Just out of curiosity, how many of you are React Native developers? Ooh, a few hands. Okay, so sorry, the other 100 people here. This might not be that interesting. So obviously there are problems with animations in general. That's a big topic. We found that using the React Native animated was good enough as long as we set use native driver true. There are other libraries like Reanimated that are very good, but we found that for simple animations, this was enough. A super important thing is using inline requires. And that is because when you've got some sort of like a set of modules in your application, including images and native modules, etc., what React Native does is it pulls it into one bundle, it bundles it up, and it loads it all into memory the moment it starts up. That means that your memory usage will be huge, but also the amount of time it takes to initialize all of the modules is really big, especially on older Android devices. So what we want to do is use inline requires that will only run when we are actually using that piece of code. That on its own won't do that much difference. What we also need to do is help it by using run bundling or lazy packaging. The lazy packaging is like a super new thing. If you're interested in that, like, let me know. But the run bundling is something that comes out of the box with React Native right now, and you can just sort of like flip it with a switch. So it's very easy to like get a lot of performance boost if you're using inline requires. And then when you're doing native and you're measuring stuff, it's important to look into this awful thing. We use profilers a lot. They're relatively easy to understand because they're just graphs of how much memory and CPU is being used. But this is an Android systrace, and it's relatively complex to figure out what it's actually saying. But what we want to focus on is having a look at the CPU usage, see where the spikes are, see what cores are being used by what threads, and then to remember that there is this MQT.js thread, which is the JavaScript thread, and then there's the MQT, I think, native, which is the native thread. So those are the two to look out for to check what they're actually doing at any given point. Last thing is routing. This was like the worst issue for us. We decided to use React Route to Native because that is the default on web, so we thought that might be nice in native as well. The problem is that they change routing through state changes. That meant that whenever we wanted to navigate user, it would need to update the state and render out everything that was underneath it, and it was literally remounting the whole screens. So it was a huge amount of work. So what happened was the user would click something, and then there would be a 3-second wait until they would be redirected to an empty screen where the whole thing would slowly start rendering. So after 12 months of work, we all had to stop, freeze all development, and start rebuilding navigation. And after that, we decided to use React Native navigation, which is a bit of a hacky approach for many reasons. So my recommendation right now would be to use React Navigation, which is the sort of generally supported library by most React Native devs. And just like a word of caution to sum it up, optimize wisely, make sure you measure, make sure that you actually understand why things are being slow. That will help you so much to decide how to optimize in a way that actually makes sense for you and for your project. And that's everything. Thank you very much.